Continuing this morning's theme of student success, I'm very pleased that we have two student research presentations. Our first is from two undergraduate researchers and members of the MSU iGEM team. iGEM is an international competition in which student teams actually genetically engineer synthetic machines, and so you'll hear a little bit about that. Their mentors are assistant professors Danny Ducat, Bjorn Hamburger, Michaela Teravest, and Tim Whitehead. It's very exciting to see some of our most promising new faculty mentoring student researchers. Our faculty's willingness to bring undergraduates into their programs provides unique opportunities for MSU students. I want to extend my congratulations to the students and also my sincere thanks to these mentors and all faculty research mentors on campus. Yes.
Yes, thank you very much to give us the chance to introduce briefly the iGEM program and of course to give the students a chance to introduce their research. So iGEM is the international genetically engineered machine where students sacrifice their summer to work full-time in the lab to engineer microbes, for example, for travel in space, for making the world a better place. This program involves a lot of outreach, and you'll hear a little bit more about that. Overall, at the end of the summer, the students will go to MIT and present their project at the global competition, and we are absolutely proud to have had the first iGEM student team at MSU last year, and they managed to get a bronze medal in Boston. And with that, I will pass on the microphone.
Good morning, everyone. Thank you so much for this opportunity for us to present about our research experience that we had last summer with some amazing faculty members in MSU. And finally, to compete at the International Genetically Engineered Machine Competition. It's a synthetic biology competition. So with that, in the next couple of minutes, I would like to explain a little bit about iGEM as well as the big picture of our research project and our journey to iGEM conference in Boston. And so first, I want to talk about what is iGEM. iGEM is abbreviated from International Genetically Engineered Machine. It's a worldwide synthetic biology competition which held annually by MIT. And there is a picture. This is a picture of iGEM, all of the teams in iGEM. There were 5,600 participants across 42 countries. And the goal of iGEM is to work in synthetic biology to solve real-world challenges, such as like plastic degrading bacteria or electricity producing microbes and that kind of stuff. And so there were over 400 teams that is competed in iGEM 2016. And in iGEM, we also spend a lot of our times over the summer to build genetically engineered biological machine from microbes. And before I'm talking into detail about our research project, I'm gonna go to introduce you about our members in iGEM team. So we have 3 undergraduates, 2 mentors, and 4 principal investigators. So from the far left in here, we have Dr. Tim Whitehead from College of Chemical Engineering. And Dr. Bjorn Hamburger, which just came over here, just introduce about us. And then Eric Young, which is a graduate student mentor. Darwin Walger-Kane, he just graduated from Material Science and Engineering. And myself, Lauren Tamm, which over here. And Dr. Michaela Teravest, he is a professor in Department of Biochemistry and Molecular Biology. And not pictured in here is Dr. Danny Ducat and Adam Woodruff as our mentors. And so I want to talk a little bit about our research project. So before all the lab works and research began, we had a weekly meeting where we talked about what do we want to work in the summer. So we decided to work to engineer cold-tolerant cyanobacteria that would be able to grow on Mars and replicate on Mars. But then the big problem in here is that on Mars, the average temperature is about -67 Fahrenheit, which is far away with the optimal growth temperature for cyanobacteria, which is around 86 Fahrenheit. And so we decided to engineer cyanobacteria to be able to grow on Mars by genetically engineered their cell components. And then from there, we also built photobioreactors so that we can grow this cyanobacteria and bring that to Mars. Besides our research project, we also designed some artworks like this iGEM logo that we bring into our MSU iGEM website, as well as to represent officially as MSU iGEM team logo. And we also developed a website which is open to public if you want to look over into detail about our research project. We also have an outreach event where we partnered with the local science museum at Impression 5 here in Lansing to kind of promote the interest of science to children and their families. And finally, last but not least, we presented at MIT in Boston to demonstrate our research project to all the iGEM community across the world, and we were awarded with a bronze medal for our contribution. And next, I will give Lauren to talk about our research project.
So for those of you who don't know, cyanobacteria are actually one of the main bacteria that help or that create blue-green algae. So what we wanted to do was that, cyanobacteria are also very good producers of like biomass, so biofuels, things like that. And what we wanted to do was we wanted to decrease the temperature through which cyanobacteria could survive at. And the reason for that was our goal, or I guess not our goal, but NASA's goal is to have people on Mars by 2030, meaning that they need fuels and things. So if we could have these cyanobacteria create biofuels on Mars at these lower temperatures, that would be a really great thing to have. So throughout our whole project was just trying to decrease the temperature through which they could survive. One really cool aspect of our project was that we created our own bioreactor. So bioreactors generally can cost like thousands of dollars. What we wanted to do was we wanted to kind of replicate how this would be in like real life. So we want a continuous growth of our cyanobacteria. Since we didn't have thousands of dollars to go and spend on a couple bioreactors, we found a lab in Washington which actually had created a bioreactor in their lab themselves. So we got in contact with them, find out how they did it, and then kind of adjust it for our own project. So we were able to create it actually out of materials that we had in the labs that were available to us. So it was in a styrofoam box to help maintain a temperature. We had lights in there, LED lights which we had put in, but we ended up creating these bioreactors for just a couple $100 compared to thousands. So that's one really cool aspect of our project. Some of our activities that we have done. So as Pamela mentioned, we did get to present in Boston at the end of the entire iGEM season. So we started March 17th, I believe, was our very first day of meeting with the team, and we went through October. So throughout this whole project, we got to present a couple times. So this top picture with the poster is actually us presenting at MSU during the summer undergraduate presentations. And then that picture on the right is us at the Impression 5 for our outreach event. So we were able to partner with Impression 5. We had a couple activities where children who were in the museum that day got to learn more about synthetic biology, genetically engineering bacteria. And then they had this fun activity where they could actually color their own superhero bug. And then we also made sure to have fun during the summer. So this bomb picture is, we had ice cream on Fridays and grilled cheese on Mondays. So we were really close to the dairy store, and we really made sure to make time for that. The picture all the way on the left is us on our way to Boston for our final presentation at the iGEM Giant Jamboree, the big conference. And then after the entire March to October process, we were featured in MSU Today for the work we had done. And of course, we thank all of our sponsors. We would not have been able to do anything without them. All of our mentors, all the help and materials they were able to provide to us. Thermo Fisher and Corning also donated a lot of materials to us, which was really helpful. So, yeah, thank you. Do you guys have any questions?
Questions, comments, questions? So then I've got both of you here. So we're talking 5 to 10 years from now. What do you want to be really thinking about and doing? 5, 10 years from now. Tough question.
So, it's kind of funny. I'm a food science major, so it's not as synthetic biology related. But one thing I hope to do is product development, but I can also bring what I did during this research into it, just because cyanobacteria also, they can produce sugars. So I'm not entirely sure yet what I want to do 5, 10 years down, but yeah.
I think for me, I want to make like biofuel, more of like massive production from cyanobacteria.
Thank you for representing Michigan State University so well. Thank you. I think that if you look at this project, and Steve and Satish are smiling, the capacity to give undergraduates a difficult problem that NASA is looking at in terms of, you know, what's going to happen on Mars in 2030 and needing all of these things, and how you can use relatively simple materials, ingenuity, creativity with great faculty members in order to be able to think through those issues and have that experience. And I know that David Washburn sort of salvaged to decide whether that little gadget is patentable that you all made. So he may be touching you at the end of the meeting. But that gives you a sense, I think, of the depth of the undergraduate research experience at Michigan State. And it's very hard, Steve, to pick one of these to do.